Class 11th Chemistry, Unit 3, Classification of Elements and Periodicity in Properties. In this video, we will discuss about electronic configurations of elements and the periodic table. First one, electronic configurations of elements in periods. Period indicates the value of n. N means principal quantum number for the outermost or valency shell. In other words, successive period in the periodic table is associated with the filling of the next higher principal energy level, like n is equal to 1 or 2, etc. It means each period starts with the filling of new principal energy level. Like second period start by the filling of second cell, third period start by the filling of third shell in the same way. The number of elements in each period is twice the number of atomic orbitals available in the energy level that is being filled. The 4f and 5f inner transition series of elements are placed separately in the periodic table. Now, what are the reasons for this? Two reasons are there. First one is to maintain its structure, and second one is to preserve the principle of classification by keeping elements with similar properties in a single column. Now, we'll try to understand how many elements are present in a given period. Okay, like period number 1, first period. It starts from the filling of first cell, and as we know, in first cell there is a one subcell, that is 1s. Okay, and in 1s there is a one orbital, and that is also the 1s orbital. One orbital is there. That's why number of elements in the first period is 2, and these two elements are hydrogen electronic configuration 1s1, helium electronic configuration 1s2. Second period, it starts with the filling of second cell, and in the second cell two subcells are there, 2s and 2p. In 2s there is a 1 orbital, in 2p there is 3 orbital. Total number of orbitals which are filled in second period is 4. That's why number of elements 8. And these elements are starting from lithium atomic number 3. Electronic configuration is 1s2, 2s1. And this will end up to neon atomic number 10, 1s2, 2s2, 2p6. Third period, this start with the filling of electrons in orbital 3s and end up to 3p, and in 3s there is 1 orbital, in 3p there are 3 orbitals. Okay, that's why total number of orbitals are 4, hence electrons number of elements are 8 in third period. And these elements are sodium, starting from sodium atomic number 11. Electronic configuration is 1s2, 2s2, 2p6, 3s1, and this will end up to argon atomic number 18. 1s2, 2s2, 2p6, 3s2, 3p6. And after the 3 peaks, next period will start by the filling of 4s subcell. Clear? And after 4s electron enters 3d, and after that 4p. Now, how many orbitals are there which are filled in the fourth period? In 1s there is 1 orbital. Sorry, in 4s there is a 1 orbital, and in 3d there are 5 orbitals. In 4p there are 3 orbitals. Total number of orbitals which are filled in the fourth period are 9. Hence, number of elements are 18. And these elements are starting from potassium atomic number 19. And if we see the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and this will end up to krypton atomic number 36. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. One thing you have to note down, that is first electron enters 4s, then electron enters in 3d. But when we write the electronic configuration, this electronic configuration is writing in the increasing order of principal quantum number. Okay. Fifth period, this will start with 5s, then electron will go in 4d, then 5p. Now, how many orbitals are there? In 5s there is one orbital. In 4d there are 5 orbitals. In 5p 3 orbitals. Total number of orbitals are 9. Hence number of elements in the fifth period are 18. And these are rubidium, atomic number 37. And outermost cell electronic configuration is 5s1, and this is closed cell is represented by this krypton. In the same way, last electron of that fifth period is xenon, atomic number 54. And if we see the outer electronic configuration, this is 4d10, 5s2, 5p6. Sixth period. In this first electron enters 6s, then 4f, 5d, and it ends up 6p. Now, how many orbitals are there? In 6s, there is one orbital. In 4f, there are 7 orbitals. In 5d, 5 orbitals. 6p, 3 orbitals. Total number of orbitals which are filled in sixth period, 16. Hence, number of elements present in the sixth period are 32. And these 32 elements are starting from atomic number 55, cesium. Outermost electronic configuration is 6s1, and this xenon represents the closed cell. And this will end up to radon, atomic number 86. And outer electronic configuration is 4f14, 5d10, 6s2, 6p6. Then seventh period. In this, filling of electrons in orbitals start from 7s, then 5f, 6d, then 7p. Now, how many orbitals are filled in seventh period? In 7s, there is one orbital. In 5f, 7 orbitals. In 6d, 5 orbitals. In 7p, 3 orbitals. Total number of orbitals are 16. Hence, number of elements in the seventh period are 32. And these elements are starting from atomic number 87, francium. Outermost electronic configuration is 7s1. And this will end up to atomic number 118, Augenson. Okay. And this is outer electronic configuration is 5f14, 6d10, 7s2, 7p6. Dear student, after this discussion, you must be able to give the answer or to justify that why 18 elements are present in group in period 4 and period 5, and why 32 elements are present in period 7 and period 6. Is it clear? Then see, we have discussed that this filling of this is 3d, 4d, 5d, and 6d. Actually, these are known as the d block elements or transition elements. This is 3d series. It means electron enters 3d subcell, and this series contains these 10 elements. These are the 10 elements. Scandium to zinc, atomic number 21 to 30. The same way, this is 4d series. Again, there are the 10 elements. This is yttrium, atomic number 39. It will end up to cadmium, atomic number 48. This is 5d series. Okay. First, in this case, lanthanum, atomic number 57. And after lanthanum, there are the 14 elements which belong to the inner transition elements, or also known as the F block elements. Okay. And these are lanthanoids because these are after the lanthanum. And these 14 elements are cerium, atomic number 58, to lutetium, atomic number 71. Then in 6d series, after the lanthanoids, it is after atomic number 71, again this is 9 elements from hafnium to mercury, atomic number 72 to 18 belong to the 5d series. Again, total number of elements in the 5d series 10. In 6d series, first element is actinium, atomic number 89, and after 89, again 14 elements belong to the actinoid series, that is 5f series, starting from atomic number 90, thorium, and it will end to atomic number 103, lawrencium. These are the 14 elements. And after lawrencium, that is atomic number 104, rutherfordium, to copernicium, 112 Cn. These elements belong to 6d series. Again, these are the 10 elements. Is it clear? Now see, electronic configuration of elements in groups. elements in the same group have similar valency shell electronic configuration. That is the same number of electrons in the outer orbitals, hence similar properties. Just see the group 1 elements, these are also known as the alkali metals. We can write the general outermost shell electronic configuration NS1. Lithium, atomic number 3, this is 1s2, 2s1. Sodium 11, 1s2, 2s2, 2p6, 3s1. Potassium 19, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay. Rubidium, atomic number 37, 1s2, 2s2, 2p6, it should be 3s2, 3p6, 3d10, 4s2, 4p6, 5s1. Cesium, atomic number 55, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, then 5s2, 5p6, 6s1, and 87, francium. This is 7s1. If you observe the electronic configuration or element electrons present in the outermost shell, you can say one electron is there. That's why all these elements which have the same number of valence electron in a particular group have the same properties, because properties decided by the valence electrons. In the same way, group 17 elements. This is the general electronic configuration, NS2 and P5. Again, you can observe this fluorine. This is fluorine. For fluorine, N is equal to 2. For chlorine, N is equal to 3. For bromine, N is equal to 4. See, outermost shell. Okay. Iodine, N is equal to 5. And astatine, N is equal to 6. Is it clear, student? Thank you. Subscribe my channel to get the new videos of this chapter.